Hi everybody, today's video is on factoring polynomials. So today we're going to factor specifically a difference of squares and trinomials. So we saw in the last video how to factor a difference of cubes or a sum of cubes, and if we have four terms we're going to use grouping. So let's review that real quick. So it's so important that when you see a problem you know what type it is, so you know how to factor it, and then as we move forward we are going to start solving. So you have to know the right method based on what you see. So here I have x to the third. So that's already telling me that this is a cubic function, a cubic expression, okay? 8 is also a perfect cube because 2 to the third is 8. All right, so, and this is a difference because of the minus sign. So the formula that we use is going to be a minus b, then it's a squared plus ab plus b squared. And we talked about this last time. And we have to find a and b. So we do that by kind of doing the cube root. So that means a is x and b is 2. So I'm going to have x minus 2. Then I have a squared, which is x squared. ab is 2x, right, plus 2x, and then b squared is 2 squared, which is 4. All right, so all we're doing is plugging into that formula because this equation is a to the third minus b to the third. That's what we say. We break it down. So that's how you do a difference of two cubes. Let's talk about something that has four terms, right? 1, 2, 3, 4. Anytime that happens, we need to factor by grouping. All right, so the first thing I need to do is break it up into two groups and then take out the GCF of each group. So the GCF of the first one is x squared. So when I divide everything by x squared, I have x minus 3. And then the GCF here is a negative 4, right? Because of that minus sign, we need to take it with. So we need to divide 4x by negative 4, which is x, and 12 divided by negative 4 is negative 3. So that's only step 1, okay? We need to step 2 is to write this as my two factors. So my first factor, again, the GCF is x minus 3. We're going to have this one and this one. What I have left is this x squared minus 4. Okay, there's always two steps to grouping. But you also have to be sure that it's factored completely. So this x squared plus 4, or minus 4, sorry, is a difference of two squares. We're going to talk about this more today, but a difference of two squares can be factored. So we're going to factor it. So I have x and x. The square root of 4 is 2, 1 positive, 1 negative. Okay, and if you were to check your insides and outsides, you'd have 2 minus 2, which is 0x, because it's not there. So again, you have to make sure it's factored completely. So we are going to use this idea of a difference of squares as we move forward today. So we're going to do trinomials first. All right, trinomials have 3 terms because tri is 3, like a tricycle. And we're going to factor it just like we factored before. So I have x to the 4th plus 8x squared plus 12. That's the only difference. That now it needs to split into x squared and x squared because x squared times x squared is x to the 4th. Then I need to look for two numbers that multiply to 12 and add to 8. And I get to do this because there's a 1 out front, and remember those are just a little bit easier. So that would give me 6 and 2. They have to add to negative 8, so that means they both need to be positive. Then you need to check and see if you can factor it anymore, but these aren't, both of these are sums, right? They'd have to be a difference of two squares. So the plus sign means no, and as well as the fact that they're 6 and 2, those aren't perfect squares. So then we get to be done with that one. Okay, number 2. Remember, the crucial first step of factoring is to look for the GCF. So I'm going to look for 4x squared, right? I can divide 4, 20, and 24 by 4, and then I can take x to the 6th, x to the 4th, and x squared. I can take x squared from all of those. So x to the 6th divided by x squared is x to the 4th. 20 divided by 4 is 5. Then I have x squared left. 24 divided by 4 is 6. And I don't have any x's left. So I need to look and see if I can factor what's on the inside. Well, that's a trinomial. So I'm going to see if I can factor this. So I'm going to split it up into x squared and x squared, because again, now I have x to the fourth. It's a little different than what we did earlier this year, but the same concepts, except for now it's x squared and x squared. So now I need two numbers that multiply to 6, positive 6, but add to a negative 5. So that would be 3 and 2 or 6 and 1. But they both either have to be, one can't be positive and one can't be negative, right? Negative 6 times 1 is negative 6, so that's not going to work. So it has to be negative 3 and negative 2, because I get negative 3x squared and negative 2x squared, and they have to multiply to a positive 6. So it's important that all pieces work. And then we're done, because now I do have subtraction, right? And it might be a difference of squares, but 3 and 2 are not perfect squares. So I can't factor those anymore. So speaking of perfect squares, x to the fourth minus 16 is a difference of squares. Now we usually see this with x squared, but x to the fourth is also a perfect square, because it's the same as x squared squared minus 4 squared. We wrote it like that a long time ago, but we're going to break this up into x squared and x squared. Then 16 is 4 and 4. One's positive, one's negative. So when you check your insides and outsides, 4x squared minus 4x squared goes away because there's 0x squared in the middle. And then 4 times negative 4 is negative 16. So that's the difference of squares pattern works for quartics also. So you have to make sure it's factored completely. Well, this is a sum, so that's never going to be able to be factored further. But the second piece is now, again, a difference of two squares, but this time with an x squared. So when we have x squared, I get to split it into x and x, because x times x is x squared. The square root of 4 is 2 plus minus. Okay, so now there's no squareds left over here, so I'm done factoring. And this one can't be factored because it's a sum. So just make sure that you're factoring completely. Okay, so number 4. X to the fourth minus 16. 81, x to the fourth, and 16 are all perfect squares. So the square root of 81 is 9, so I have 9x squared and 9x squared. Square root of 16 is 4, so 4 and 4, one's positive, one's negative. The sum of two squares can never be factored, so we just leave it. It just hangs out there. I have another difference of two squares here. Now this doesn't always happen. I know it happened in these two problems. It doesn't always happen, but it can. 9's still a perfect square, and so is 4. So that's going to be 3x and 3x. And this time, since it's only x squared, I get to go down x and x. And then I have a plus 2 and a minus 2. Because this right here is a difference of squares. Oops. Meant to highlight that. Difference of squares, difference of squares. All of these are difference of squares. So we have to make sure we factor them. All right, the number 5, last one, we have to look for the GCF. So we have 2x we can take from both of these. So I have x to the fourth minus 9. Guess what? Another difference of squares. Remember, today we're talking about really focusing on trinomials and difference of squares. You still have to know the other methods, but this means I can factor this further. So, but it's going to split into x squared and x squared. And the square root of 9 is 3. So one positive, one negative to follow that pattern. I can't factor it anymore because 3, not a perfect square. So again, trinomials and difference of squares today. And we did review our sum and difference of cubes and grouping. So those are all the factoring methods that we're learning. So if you have questions, make sure you write them down now and ask them when we meet next. See you then.